Okay, so day 4, we are going to solve the whole triangle. Now, here's my triangle. So, the thing I got to know is what else do I need to solve? I have this side. I don't have this side, so I'm going to need to solve that. I'm going to need to, well, no, I don't need to solve that. I know it's 90. I'm going to need to solve both of these angles. Now, I'm going to start off by doing SohCahToa first. So, I don't want to solve this side, because then I get 3 sides and things might get confusing for you. So, I'm going to solve for this. So, I'm going to call this x. Now, you could solve for that angle. It doesn't matter which order you do this in. So I'm going to solve for this, and I'm going to label from that side is O, H, and A. So because I'm using those two, I'm using tan. Remember SohCahToa. So I have O and A. So because I've got O and A, I'm going to use tan. Okay, so the tan of x is equal to 3 over 10. Whenever I'm solving for an angle, you do what? You do the inverse. So x is equal to the tan inverse of 3 divided by 10. And I punch that in. And I get 16.7. X is equal to, well, 16.69. I'm just going to round that to 17. I usually bring my angles to the nearest degree. So that is 17. Now, it helps if you actually write this in here, because then you can sort of see what's going on. So this is 17, which means that angle is going to be what? It's going to be 90 minus that 17. Well, let's just do 90 minus 17. So that means that this one's going to be 73. Okay, so I only have to do SohCahToa once. So I did SohCahToa once. Now I'm going to, once I get one angle, I just use the minus 90 to get the other angle. And then I can use Pythagorean theorem. So I can just square these and add them to get that side. So I just need to do, well, in order to solve for y there, we'll say that y squared equals 10 squared plus 3 squared. So y squared equals the root of 109. And the root of 109 is, well, maybe I'll just say y squared equals 109 first of all. So y equals, take the square root of those. 10.4. Okay, so 10.4. There, now I have my angles, my sides have shown my work. So these are each worth 5 marks. 1 for the work, 1 for the answer, 1 for the work, 1 for the answer, and then the last one, just the minus 90. I'm not giving you any mark for work there. So these are all out of 5. Okay, next one. So they give me something different to start with, but I want to do SohCahToa to start anyways. So from this angle, O, H, and A. Now, yeah, you could get that angle, but I don't want to do that because, again, if you get that angle, then sometimes people get confused as to where they're going to solve from. So let's just do SohCahToa first from this angle. So OH and A. Now, what do I want to solve? Well, you could solve for that and that. I'm going to put my x there. So if I put my x there, I'm going to use sine to solve. So the sine of 38 degrees equals over h, which is x over 16. Whatever's on the bottom gets multiplied up, so 16 sine 38 degrees equals x. Mind the bell. So 16 sine 38 equals 9.85, which is 9.9. Okay, so this side is 9.9. Now, you got 2 options here. In order to solve for this side here, you could do Pythagorean theorem, 16 squared minus 9.9 squared, take the square root, or I could just use these 2 again. So I could use cos this time, because cos of 38 degrees equals this over 16, so y over 16. Multiply that up, so 16 cos 38 degrees equals y. 16 cos 38 equals 12.6 equals y. So this side's 12.6. And lastly, I do my 90 minus 38 and get my angle of 52 for that last mark. So check for that, check for that, check for that, check for work, check for work. Now, again, this didn't have to be solved like this. If you want to solve one side and do Pythagorean theorem, you can. That would also be your check for work. You do have to show your work for Pythagorean theorem. Or do another SohCahToa, your call. Okay, next one. This time they're giving me 72. So from this angle, I'm going to label O, H, and A. I'm going to do my SohCahToa first. Now, what do I want to solve? Well, let's solve for this. So if I'm going to use this and this, I mean, if I could have done this first. It doesn't matter. You can solve in different ways. So if I'm going to do that and that, I'm going to get, well, tan. So the tan of 72 degrees equals over a, so x over 4, multiply that up. 4 tan 72 degrees equals x. So 12.3 is equal to x. Now, again, two ways to do this. Well, you know what? I'm going to do it both ways. So this is one mark, that's one mark. Now your next mark could either be 4 squared plus 12.3 squared equals y squared. I'm going to solve for y here. And then you take the square root of that and you get y is equal to 12.9 for your hypotenuse. Or you don't have to do both of these, or you could have solved using that in this original number 4. A and h, I would use cos, so you could do the cos of 72 degrees equals 4 over y. Now, I wanted to do this mostly because I just wanted to remind you what happens when y is on the bottom. When y is on the bottom, we bring it up and bring that down. We do the switch and divide. So 4 over cos 72 degrees. Y is equal to 4 divided by cos 72. And again, you get 12.9. So, same answer either way. 12.9. So, check for that. Check for either one of these. You could have got a check for solving it either way. And lastly, take your 90 minus 72 and get that last 18 in there. 18 degrees, check. Okay, there's your answers. Out of 5, out of 5, out of 5.